Here is the retake video for the Chapter 5A test. This was for the first part of Chapter 5. So first up, we've got the table here. So we need to take this equation up here, type that in your calculator, and look at the table. So type that in your calculator in the y equals part of the calculator, and then hit second table once you've got that in there to get over to the table. Alright, so then on the table I've got negative 192. I'm going to zoom in a little bit here. Negative 105. Negative 48. Negative 15. 0, 3, 0, negative 3, 0, 15. All right, now we want to graph those points. So looking here at the graph, let's get those points on there. So the first one that's really going to fit is this negative 1, 0. And then 0, 3. 1, 0. 2, negative 3. 3, 0. And then 4 is up at 15. So I do like to put, even though that's off the graph, I like to put it up there just kind of as a reminder of what direction I'm going. Same with that negative 2 at negative 15, just a reminder of what direction I'm coming from. So now I'm going to do my best to connect these here. Let's try that one more time. So it does not have to be perfect, but do try and get to all the dots there. All right, and then over here, f of x is going what direction as x goes to negative infinity? So x goes to negative infinity, that is left. And x goes to positive infinity, that is right. So looking left, so kind of starting at 0 and looking to the left, the graph is going down. The line's going down. So this is negative infinity. As we kind of start in the middle and look right towards the end of the x-axis, the graph is going up. So that is positive infinity. The x-intercepts are the dots on the x-axis here, or you can look up at the table and it's when y equals 0. So the x-intercepts are negative 1, 0, 1, 0, and 3, 0. Make sure to write those as points. Don't just list them out, negative 1, 1, 3. We want them to be the coordinates of the point that is an x-intercept. All right, there's question 1. Question 2, match the letter with the correct vocab term. So we've got maximum, minimum, x-intercept, y-intercept, and we want to state which of those is the correct point here. So maximum means the highest, the most. So the highest point is point E here. So E is a local maximum because it is higher than all the points around it. B is a local minimum because it is lower than all the points around it. There's another local minimum. F is also lower than all the points around it. There are 2 x-intercepts, so that's on this x-axis line, A and C. There is 1 y-intercept. There will only ever be 1 y-intercept. That's on the y-axis. That's D. So we should use all of the points. There shouldn't be any left over. So quick check, Yes, we use them all at least once. Sometimes a local maximum or local minimum can be an x-intercept or y-intercept as well. So they can be used twice, but you do want to make sure you use them all. Determine the least degree this could have. So we add up the maximums and minimums. So there are 3 maximums and minimums, and then you add 1. So 4 is the least degree this could have. Now once again the end behavior. So as we're looking left and right, what is the graph doing? So as we're looking left, the graph is going up, so that's positive infinity. As we're looking to the right, the graph is still going up. That's another positive infinity. And that is the first part of the test. Moving on to the next page here, we've got some more going on with our polynomials. So first up, the word problem. Question 3. You are given a piece of cardboard 18 inches long and 18 inches wide. You want to create an open-topped box by cutting x-inch squares out of the corners. So we've seen several examples like this. So that's where we've got our piece of cardboard and we're cutting out the corners to fold up the sides and make a box. What are the approximate dimensions of the box with the maximum volume to the nearest 10th inch? What is the maximum volume of the box to the nearest 10th of a cubic inch? So we want the dimensions and the max volume. So this piece of cardboard is 18 from edge to edge, 18 from edge to edge that way, but these little squares we're cutting out are x by x. So the volume is length times width times height. So the length and width are actually going to be the same. 18 minus 2x, 18 minus 2x. So it's 2x because we're cutting this x off of both sides. So that's where that 2x is coming from. Now, when we fold this up to create a box, the height of that box is x. So the height is x. Now we want to find the maximum of this volume. So we're going to type our equation into our graphing calculators in the y equals part of your calculator. So y equals, and then type it just how we see it here with parentheses and everything. And then I'm going to look at my table first just to give me an idea of where that maximum is going to be. So in my table, I see a point that my highest point I see is at 3 and then 432. So I know my maximum is probably going to be around that 432. So I am going to go to my window and change the y maximum to, I'm going to do 450. So in your window, change the y max to, let's try 450. And then look at the graph. So I do see my maximum. I am going to trace up to the top there. And we lucked out. Our maximum is this point we saw there. So the maximum is at 432, which is when x equals 3. So the dimensions we are just plugging in this 3 for all those x's. So 18 minus 6 is 12 by 12 by 3. All right, so that one you are going to rely a lot on your graphing calculator for. You're going to need to know how to adjust your window a little bit. You're going to need to know how to find that maximum point and see that on your graph. All right, so next up are our adding and subtracting and multiplying and dividing of polynomials. So let's start right here with this adding polynomials. So all we are doing is combining the like terms. X cubed, that is my only x cubed. Now negative 3x squared plus 4x squared, I get 1x squared. 18x plus 18x, now I have a total of 16x minus 4. This one, when we have subtraction, I like to rewrite it just because that negative needs to be distributed to all the parts in that second set of parentheses. So I'm not even going to start combining anything yet. I am just rewriting what we have. So minus 4x squared minus 8x minus 1. Now I will start to combine my like terms. So there's still only one x cubed, but now both my x squareds are negative, so I have negative 7x squared. My 8x and my negative 8x completely cancel out. There's nothing left. And then negative 5 and negative 1 leaves me with negative 6. All right, multiplying. So when they say expand, that's another way of saying multiply. So when we have a long polynomial like this, I like to use the box method. So I'm going to make my box here. So x cubed, negative 3x squared, 8x, and negative 5. X and negative 3 on the side here. So now I multiply together everything, or the two numbers on the sides of the box. So I've got x to the 4th, negative 3x to the 3rd, 8x squared, and negative 5x, negative 3x to the 3rd, 9x squared, negative 24x, and 15. So now the like terms are going to be diagonal from each other. So I'm going to combine the like terms on the diagonal here. There's only one x to the 4th. Negative 3 and negative 3 do not cancel out. It is negative 6x to the 3rd plus 17x squared minus 29x plus 15. All right, so that is expanding or multiplying two polynomials. The next one here is our synthetic division. So we start by putting the opposite sign of this number here on the bottom up on the side. So positive 3. And I know this might look a little bit different than how some of you saw it, but it's going to be the same basic method here. Just some of these little bits might look a little different to you. And then across the top, we need all the coefficients from this top polynomial. So 1 x cubed. If it helps to write that 1 in, you can do that. Minus 3x squared, 8x, and negative 5. All right, leave a line in between and then kind of draw a line to get our answer underneath it. The first number comes straight down, so we've got 1. Then we multiply this 1 with the 3 up on the side, so we get positive 3. So we multiply to go up, we add to come down. So negative 3 plus 3 is 0. We multiply to go up, 0 times 3 is still 0. We add to come down is 8. We multiply to go up, 24. We add to come down, 19. And then I like to separate that last number because that is our remainder, and that's treated a little bit differently than the rest of the answer. So for question 7, they're asking us, what is the remainder? Well, we just found it. The remainder is 19. All right, last question. Factor this polynomial given that x minus 6 is a factor. So factor completely means that we'll start by doing the synthetic division, but then we'll be able to do our kind of regular quadratic factoring we learned in chapter 4. So I'm going to start by putting a positive 6 up on the side, and then all the coefficients, all the numbers in front of these x's. So once again, if you like to put that 1 in front of the x cubed, we have 1x cubed, negative 3, negative 16, and positive 12. So the 1 comes straight down. Now the 1 and the 6 multiply. We get positive 3. The 3 and the 6 multiply. We get 18. Add those together and we get 2. Oh, I'm noticing I forgot this negative. I'm going to put that there on the 12. 2 and the 6 multiply. We get positive 12, and those cancel out, leaving a remainder of 0. So we knew we should have a remainder of 0 because x minus 6 is a factor. When they tell you something's a factor, you have to have remainder 0. So that's kind of one way to check your work. Now we are going to put all these x's back in. So we started with x to the third, but we divided out an x. So now we have x squared plus 3x plus 2. And we want to factor that. So we want two numbers that multiply to 2 but add to 3. So those two numbers are 2 and 1, x plus 1, x plus 2. And then our third factor is the one they gave us, x minus 6. So don't forget to bring that factor down. And that is the complete factorization of that polynomial. And there is the second part of the test for you. Good luck on your retake.